Welcome to this week's Contrarian Coding News. The return to generalization and the unseen costs of specialization in large language models. The thesis that the future of large language models lies in specialization and efficiency overlooks a fundamental and potentially more powerful alternative: a renewed focus on generalization. While the current trend points towards specialized models, a compelling contrarian view suggests that this approach will ultimately create significant problems, leading us back to a preference for highly generalized monolithic architectures. The push for specialized models like mixture of experts and domain-specific fine-tuning introduces several critical drawbacks. The primary issue is knowledge fragmentation. By dividing a model's expertise into smaller domain-specific components, we risk losing the emergent, interconnected knowledge that makes large, generalist models so powerful. An MOE model, for example, may be efficient at a specific task, but could struggle with complex problems that require synthesizing information from multiple domains. A generalist model, trained on a vast and diverse dataset, possesses a broader understanding of the world, making it more adaptable and creative in its problem-solving. Furthermore, the focus on specialization creates significant operational overhead. Building, training, and maintaining a vast ecosystem of specialized models for every possible use case is a logistical nightmare. Each model requires its own training data, fine-tuning process, and regular updates, leading to a sprawling and costly infrastructure. The thesis of efficiency is a mirage. The computational savings on a single inference are offset by the exponential costs of managing a multitude of models. Instead, a renewed focus on building a single, highly capable generalist model presents a more sustainable path. This super-generalist model could be continuously improved and updated, with its knowledge base growing in a unified, coherent manner. This approach would be more scalable and cost-effective in the long run. The true innovation, from this contrarian perspective, is not in making models smaller and more specialized, but in making a single model so large and capable that it can handle any task with unprecedented accuracy and adaptability. The future may not be about 1,000 specialized tools, but one incredibly versatile one. The nuanced reality, a potential synthesis. While the contrarian view is strong, the most likely future is a synthesis of both specialization and generalization, rather than a complete victory for one over the other. The two approaches are not mutually exclusive. Specialization for generalization. Some researchers argue that a form of specialization is actually necessary for a model to generalize effectively. For instance, an LLM might have specialized internal modules, like a mixture of experts architecture, that allow it to learn and handle different types of data or tasks more effectively. The super-generalist model could be built from specialized parts with a routing mechanism that intelligently directs tasks to the most appropriate expert within the model. This allows for both efficiency and broad capability. A generalist core with specialized add-ons. Another likely scenario is a future where a powerful generalist foundation model acts as a core for most tasks. For highly specific or sensitive domains, like a hospital's internal database or a bank's financial records, smaller, specialized models could be fine-tuned on top of this generalist core. This combines the adaptability of a generalist model with the precision and security of a specialized one. The future is unlikely to be a simple choice between one or the other. Instead, it will be a dynamic interplay between these two forces. The final outcome will likely be a synthesis where we leverage the power of massive generalist models for their adaptability and broad knowledge, while also using specialized techniques to optimize for specific domains where precision, security, and efficiency are paramount. This synthesis will be the next major phase of AI development, bridging the gap between two competing yet equally important philosophies. And that wraps up another edition of Contrarian Coding News, where the status quo is always up for debate.